here, there's not as strong evidence as a direct measurement. But taken together, these are pretty good evidence that cough will be okay. Over here, I have two fairly direct measures. One is a positive measure, and one is a negative measure of evidence that the coffee will be adequately, for my wife. So, without more information, though, when you look at this and think of it as the assurance case design, this is something we developed to describe how we're going to provide assurance. While it can address risk, the IEEE specification is pretty clear about how you would capture uncertainty in all of these things. But it does not directly support an argument about consequence. That is, I haven't put anything into the assurance case design that would say having, for example, 3.5 minutes would be disastrous versus 3 minutes on the coffee delivery aspect. So there's a couple of things that are kind of unique about this. This is something that we designed. This is not something that we necessarily derived exactly from the system. It is related to the system that we're working on, but it is our plan for providing assurance. And by the way, this contrasts dramatically with the system model type approach, where you have the, as has been stated before, the state explosion when you get down to the lower levels of description of, especially of any reasonably complex system. The assurance case only needs to go as far as it needs to go to provide us assurance. So the question that we had, and this was one of the first questions that I approached on the assurance case or capabilities development, was where to start. What are my top level plans? And as I said up here on the right, it's initially a major goal. And what I found out was that literally you could not walk across the street without finding some place where you could come up with some sort of an objective that would be appropriate for an assurance plan, for a top level plan. And this is where I found that I put myself in the position of the stakeholder. And in order to do that, we developed a bunch of different perspectives. Now, for example, one way that you can develop perspectives on where to start with assurance plans is that of system safety, like I said before, or you could go into software development requirements and come up with 7120 NASA standard. Give you another place that you could start. You can start with behavioral descriptions, top-level descriptions of behaviors that you want, or you can go to project requirements. All of those are valid to start with top-level plan. In practice, we find there's kind of a self-similarity. That is, let's say on some certain level, and well, here, I'll just advance this a little bit so it'll become a little bit more interesting. You get down to a certain level with the assurance cases, and you'll find that the same building blocks get used to show different high-level assurance case claims. So in the end, there's not nearly as many assurance cases to show anything as you might think. Perspectives and planning, we talked about this guy a little bit. Wanted to point out also that my experience in doing the capabilities development was that the software lifecycle type approaches sort of give different decompositions in the system and human safety. Although they're related, in the end, you always end up talking about the same kinds of things at the lower levels. The upper levels are a little different. I regard argument is the art of assurance case. And there's a bunch of different decompositions that I find useful. Appeal to specificity, which basically is the detail to support a more general claim. And let's say you have a claim which says there's no way that 32 volts will fail. And then the subclaims on that might be there's no way that this bolt 1 fails, bolt 2 fails, bolt 3 fails, bolt 4 fails, and so forth. Generally speaking, I find there's little uncertainty in those. I have not had a lot of opportunities to do that. I found that the other sorts of decompositions tend to work better for me, at least in the capability development project. The appeal to usage is very common. This is basically a behavioral type decomposition. We oftentimes use a scenario to decompose the subsystems by the required actions. What it has to do is A, then B, then C, then D. And then what we do is, using this appeal, do the claim for each of the behaviors underneath that. I find that there's some uncertainty in it because oftentimes we as IV&V will be generating these usages. In fact, even the project can be generating these usages. Sometimes steps get left out, little things get left out, so or mistranslated, if you will. So I think there's some uncertainty occasionally in the field of usage. And by the way, the 3 questions where you decompose a claim by saying, well, this is what is supposed to happen. This is what happens when this is what's not supposed to happen, and this is what happens when things go wrong with a graceful degradation. That's also a useful form of this field of usage. In a way, that's kind of building sort of an implicit scenario. So those I found actually were the 3 questions decompositions are pretty useful to apply to lower levels. If you do it at a higher level, oftentimes it turns messy. Finally, appeal to architecture, where you use the software architecture to decompose. For example, you have various modules and so forth. There's no uncertainty in that, or very, very little. I mean, there's a chance, I suppose, that in the end the project could change their architecture decomposition, but it doesn't happen real often. And usually you end up, once you've used an appeal to architecture to describe what the submodules are or the subcomponents are, you're going to come right back to do an appeal to usage, because then we're talking about how the modules are used. And typically, it only takes a few iterations of those 2 to get down to a level where you have solid evidence to show that there's some exposure. So, also, I'm going to point out that assumptions are often necessary, especially when you get into situations where, for example, one of the cases we used was a reset side swap during the JOI, planetary orbit intercept, and we had to make assumptions about the behavior of the hardware in order to make the assurance cases come out reasonably well. As soon as I started delving into the gory details of the hardware, became very messy, and I had to make a lot of claims that really didn't make a whole lot of sense. So use an assumption on those particular pieces. If it's not part of the core argument and sort of out of scope for us, put an assumption and walk away quietly. That saves a lot of time and trouble. The other part of this is when to stop, because oftentimes I've caught myself working on really, I had the evidence that I needed already at hand. Completeness comes down to a few things, like are all of the claims fully decomposed? Do you have evidence that you can point to for the claim? And are the assumptions described? And evidence is directly relatable, are easy for me to say. This is kind of an interesting thing because oftentimes we have evidence. For example, we'll have a report that's a requirements analysis report. And within that report, we might address 500, 600 requirements or a table within SMART, for example. And the question is that really evident? And my view of this is that it is evident. However, the strength of the evidence is proportional to the ability of the reviewer to go find that and make sense of it. If the evidence points to a table on page 23, line 7, where we have done the analysis and this is the answer to it, that's really strong evidence. If it's pointing to a document with no reference to it at all, and you're really not even sure where it is, that's not strong evidence. So I think the power of the assurance case depends a great deal on how we choose what we're going to use for the evidence in the end. Generally speaking, I found that the lowest level claims could be supported by one or more low level requirements. For example, in my CD, typically at somewhere about the bottom level, it would be the equivalent of about 4.5 requirements. I would have maybe a dozen level 5 requirements. I would say, okay, this requirement would be evidence related to my particular claim. And then I would have tests and so forth to support those. So it appeared to be that you have to end them more or less. I think at the system software architecture level, there's not much point going very far below that. And in fact, you might be able, in some cases, let's say you have a system where you're going to be satisfied with the assurance design if you simply have a system level test that covers a particular function. There's no reason to expand it below that. So, again, this is also part of design process. What evidence you want to use in the end. Which brings me to this question. If you read the GSM standard, it talks about designing assurance cases as both top-down, that is starting from the top level of claim, and working your way down to evidence, and from bottom-up, which uses the evidence to build whatever top level claims you can. And then it's kind of at the end it talks in the third, which basically means you use both. You start top down, and then you get down to a certain level and look at what evidence you have and build up. I think from what I've seen, practical use is that we use both the top down and the bottom up. We're really concerned, and we know most of the structure of a system when we start doing our assurance design. The top level claims provide really the entire motivation for the assurance case. So it's, building from the bottom up basically kind of makes it a little bit rudderless. Building from the top down without looking forward to where the evidence is sort of doesn't give us a map of the territory very well. So I find the ones that I did that made sense kind of work in both directions. In my particular case, in the for the capabilities development project, we did a PBRA program plan, basically using this assurance case, and in particular, this justified our using of the planetary orbit intercept. This was a generic spacecraft that just was going to planet X, doing nothing. So the planetary orbit intercept, out of doing our PBRA, was just picked as being basically our driver for the entire system. And then we used the PBRA to map to the assurance case. And the light arrows that you can just barely see on the page actually was what the result was. We could map the scenario steps to elements within the assurance case because basically we use those scenarios to develop the arguments when we had behavioral decomposition. So what my bottom line was here is it looks like we can in general map scenarios to arguments, which are basically going to be the decomposition by behavior, and then the scenario steps, which are the levels below that, map back to my claim. So there is kind of a one-to-one relationship between the scenarios, the PBRA, and elements within assurance cases, and the ones that I've been able to put together. Now, static code analysis is I won't call it a special case, but it's a sort of a different case. We generally speaking, not always, but generally, do large parts of the module at one shot with static code analysis. And the question was, well, how do we show this as providing insurance? Because in the kind of the general case, you can use requirements, tests, and so forth. Those are very obvious connectors between our evidence and the assurance case to bubble up. What we think, I think the approach to take here is it applies to the project in general and is traceable to the architectural components. For example, you might be able to throw in a claim that module so-and-so is free of the implementation flaws. That's probably good enough. Then you can point off to your the static code analysis to come up with a specific or specific reasons why you think so, or specific reasons why you think not. The other one that's pretty interesting to me, and I kind of passed over this a little bit in the beginning, was how does uncertainty fit into the picture? The IEEE 15026 is very specific about uncertainty for basically almost all of the elements. But it does not say much about how you combine components of uncertainty for different parts of assurance cases. And it doesn't talk about the quantity or the combinatorial analysis and so forth. And as a result, we ended up not picking up this particular COBRA. But if we did have uncertainties, if we wanted to generate uncertainties, do we want to do that? And this kind of gets to one of the interesting questions that comes up is, if IV&V independently generates a measure somehow of the uncertainty of some of these top-level goals, what does that really mean? Our opinion, the uncertainty might be for some. I think that's pretty dangerous ground. We've had a lot of conversations in various meetings about what that would really mean. And I'll basically table that one for the next go around and see if we can come up with something that makes sense on that. I do like the Schrodinger's cat approach eventually. It would be nice if we actually had an uncertainty that would go with it. But the key thing that I get out of the assurance case design is that it's a design for assurance and not necessarily something that's trying to model what's going to go wrong. So to me, uncertainty is not as big of a picture, not as big of an item in the long-term picture of this. Is the basic idea of how we're going to design assurance for our project. And for something that you really like, this is the end. We've got some hot spots for development. Algorithmic blind spots are interesting. I didn't bring this one up, but for example, there are parts of the system which kind of go into a big black box. And when you have something that involves like a lot of matrix algebra, an example of that's like a Kalman filter or various things, you end up with stuff that doesn't lend itself to making assurance case-like statements on it. And I think on those, you end up making a top-level claim about what this is going to do, and you produce the evidence that says it works the way it's supposed to, and you walk away quietly. Scoring and ranking on these should be something possibly that's developed in the process of the assurance case, but the assurance case itself doesn't give you a means to rank that. That's got to come from someplace else. I think you could code it and you could put it into the assurance case as a way to kind of capture it. The other part is it would be nice at some point to start, working these particular process against a real project that's from the top down. It looks to me as though it's not as bad as one might think. Is it possible to do a practical and full spacecraft assurance case? Yes. It might take work. It's going to be a life cycle project because it will go along as you develop your assurance. Step you take on that is going to build on the assurance case that you're going to use with it. I put a little bubble out there about structured GSN because there is this material within the GSN description which gives you structured components that I did not use in my original CD, just trying to keep it really simple. That would be a big step in making the assurance case networks much more readable and easier to track, and would allow allows for the object decomposition of the assurance cases themselves to be a lot more comprehensible. The practical assurance case useful, and I put in there well designed. I'm not sure that's exactly the right word for it. Once you design the assurance, and going much beyond that or trying to do something else with it is something that is going to be a time maker. Also, is it difficult to write top-level claims? I argue not at all. Top-level claims, if you don't know what the top-level claim is and start doing an analysis, probably should really stop and think about what the objective of your analysis is when you find through. The top-level claim, once you decide what that is, your top-level claim maps exactly to that. Is it difficult to develop arguments for decomposition? I found a couple that were a little tricky, but in general, no. I think they became pretty obvious, especially if you follow the kind of pattern of doing architectural and then behavioral decomposition, sort of alternating. They seem to go pretty well. And then finally, uniform and systematic process for each project. And I'm finding more and more reusability of assurance case design. And it comes from thinking of this as design rather than as a system model. When you think of the design, capturing the design, large parts of this will be repeatable for anything that has basically the same similar characteristics. So, and this is for me kind of a change in perspective from the beginning of the project. I thought when we started on this thing that we would find that they weren't particularly reusable. I think now that I've been through this and done some other work on it, I think possibly there's a good chance for reusability of these substantial components because it doesn't reflect the system, it reflects assurance design. So, open to questions.
Actually, your time's up, so we're going to send you straight over to the breakout room, and we are having a 10-minute break here because we gave you 5 minutes extra. So we're going to shorten our break to 10 minutes instead of 15 minutes, and we'll pick back up here at 2:45.
All right, very good. Thank you.
Thanks, Pam.
You just need one regular.